The best model on a leaderboard can be the wrong production choice. Cost and latency are quality dimensions too. This AiQualtest episode gives product, engineering, risk, and quality teams a practical, vendor-neutral playbook for cost, latency, or quality trade-offs in 2026. Use a simple operating loop: measure, trade, choose, and review. That loop keeps conversations concrete when stakeholders disagree about quality or risk. Why this matters: enterprises must serve users within budgets and SLOs. Explicit trade-off analysis prevents silent overspend or sluggish UX. Scorecards that include all three axes support better architecture decisions. Enterprises shipping AI into banking, insurance, healthcare, and digital operations cannot rely on hallway demos. Buyers, auditors, and internal second-line risk partners ask for repeatable methods, version artifacts, and clear ownership. If you cannot explain how you tested and what evidence you keep, you do not have AI quality, you have optimism. Core concepts come next. Do not memorize jargon, operationalize each idea into cases, metrics, and gates. Concept 1: Unit economics. Track cost per successful task, not only per token. Failures have retry costs. In practice, treat this as a measurable property, define what good looks like, attach evidence, and track it across model, prompt, data, and tooling changes. Concept 2: Latency SLOs. Define P95 targets by workflow. Slow correct answers still fail users. In practice, treat this as a measurable property, define what good looks like, attach evidence, and track it across model, prompt, data, and tooling changes. Concept 3: Quality under budget. Evaluate candidates at fixed cost/latency envelopes. Fair comparisons need constraints. In practice, treat this as a measurable property, define what good looks like, attach evidence, and track it across model, prompt, data, and tooling changes. Concept 4: Cascade designs. Route easy cases to cheaper models, escalate hard ones. Measure end-to-end quality. In practice, treat this as a measurable property, define what good looks like, attach evidence, and track it across model, prompt, data, and tooling changes. Concept 5: Caching effects. Account for cache hits in cost and latency reports. Otherwise, numbers mislead. In practice, treat this as a measurable property, define what good looks like, attach evidence, and track it across model, prompt, data, and tooling changes. Concept 6: Executive views. Present trade-offs as options with residual risk, not a single magic number. In practice, treat this as a measurable property, define what good looks like, attach evidence, and track it across model, prompt, data, and tooling changes. Here is a real-world pattern. Setting: Airline Operations Center using AI to draft disruption messages for agents. The highest quality model blue latency SLOs during peak irregular operations. A cascade design kept quality on hard cases while meeting P95 with a smaller model for routine drafts. Cost per message dropped without increasing complaint rates. Leadership approved the cascade after reviewing a 3-axis scorecard. Notice the pattern: define scope, run controlled tests, capture evidence, decide with named owners, and feed failures back into the next cycle. That is how AI quality becomes a system property, not a slide. Common mistakes: slow mature programs. Mistake 1: Optimizing quality alone without cost and latency envelopes. Teams that skip this create silent risk that surfaces in production or audits. Mistake 2: Reporting token cost instead of cost per successful task. Teams that skip this create silent risk that surfaces in production or audits. Mistake 3: Ignoring peak load latency when choosing models. Teams that skip this create silent risk that surfaces in production or audits. Mistake 4: Hiding trade-offs behind a single composite score. Teams that skip this create silent risk that surfaces in production or audits. The antidote is discipline: small goal sets, explicit thresholds, change control, and monitoring that connects production incidents back to evaluation suites. Key takeaways for your team. Takeaway 1: Measure cost, latency, and quality together. Takeaway 2: Compare candidates under explicit envelopes. Takeaway 3: Consider cascades and caching honestly. Takeaway 4: Present options with residual risk to leaders. Write these into your team wiki and release checklist so they survive staffing changes. Your next steps this week: add cost per success in P95 latency to your next model comparison scorecard. Then, prototype a two-tier cascade for one high-volume intent and measure end-to-end quality. Keep the artifacts, prompts, datasets, scores, approvals so you can defend the decision later. Where this fits the AiQualtest method, learn the foundations with AiVELabs, practice with hands-on cases, and validate with governed evaluation evidence. Visit aiqualtest.com and learn.aiqualtest.com. Thanks for watching. Subscribe for weekly AI quality, evaluation, and governance episodes. Additional depth for practitioners: treat cost latency quality trade-offs as a controlled experiment. Version the inputs, freeze the environment where possible, record who approved exceptions, and rerun after every material change, model upgrade, prompt edit, retrieval index refresh, or tool permission change. Pair quality metrics with latency, cost, and safety signals so trade-offs are visible to product owners. When results regress, open an incident-style review even if the feature still looks fine in a demo. Governed teams prefer boring, evidence-backed releases over surprising wins that cannot be reproduced.